on this, we're seeing clear signals shaping manufacturing. Persistent labor shortages, rising wage pressures leads to early stage of humanoid deployment, starting from automotive production. So these are not just technology innovation, but a clear signals of bigger transformation in how factories operate in the next decades, from fixed automation to flexible and intelligent system. But here's the thing, none of this agility is possible without serious compute power. From vision processing to real-time decision making, it's the chip insights that define how capable this system can be. So, Saloni, what's changing inside the semiconductor that enabling all this?
Thanks, Joanne. From a semiconductor viewpoint, the key enablers are advancements that we are seeing right now in semiconductors and specifically high performance AI chips and edge computing. So each robot needs $1,500 worth of semiconductors and more than 5,000 chips. Just go in an example like in humanoid. These allow humanoids to process vast amounts of sensor data locally, reducing the latency tasks that such as object recognition, adaptive pathfinding, and also dynamic factory environments. So companies are integrating more efficient neural processing units that can handle complex algorithms without overheating or excessive power. This is very crucial now for robots to transition right from their scripted actions to truly autonomous behaviors. But how do you think this ties back to robotics hardware demands, Joanne?
I think mechanically, from hardware perspective, definitely the race gets more aggressive. So I would think the Chinese makers are the ones to watch. They can actually scale from prototype to mass production in months with cost up to 40% lower and with full control of their entire supply chain. And obviously, they are backed by state support, government support. They are able to roll out humanoids into factory faster than the European and Japanese rival can test them. My view, I think they won't just win on cost, they will win on speed, learning from real deployments, and eventually rewriting the global manufacturing rulebook. Again, back to you, Saloni. What do you think from the processor and also the AI chip perspective?
What we are seeing is quite fascinating, Joanne. Chinese manufacturers right now are, as you said, driving robotics innovation, specifically humanoid, through multi-core AI processing processors, combining CPUs, GPUs, and NPUs for seamless task switching. They're moving from basic tasks from welding to quality inspection. And the real game changer right now is gallium nitride semiconductors, which are offering switching frequencies 10 to 100 times faster than silicon and are enabling precise motor control and lighter power systems. So, as robots integrate more high resolution sensors and move massive data streams for processing units, it's becoming a limiting factor for truly autonomous capability. So we are seeing a synergy right now between mechanical systems and the AI chip architecture and data connectivity, which is all tying up together. So if we look this in an overall perspective and in closing, these developments in semiconductors are now vital for unlocking the full potential of robots and humanoids in manufacturing and smart factory environments. The synergy between AI driven chips and mechanical innovations will drive more intelligent and adaptable factories. Thanks for this insightful discussion, Joanne. Viewers, stay tuned for more on emerging tech trends.